Again, just some things we're going to have to remember now. So 11C, the antiderivative of something in that form. So ax plus b all to the power of r. Now, do you remember the chain rule? I'm sure you do. So if we had ax plus b all to the power of r plus 1, we can use the chain rule to find, do it if you want, that the differential, so f dash of x is a r plus 1 brackets ax plus b close brackets all to the power of r. Similarly, if we wanted to go the other way, so if we wanted to work out what the integral of this bit here, ax plus b to the power of r, with respect to x, it's this. And again, we can keep saying r can't equal to -1, r won't equal to -1. Take care, because the a there, so there's going to be a number here that could be a 7x or a 5x or a minus, will go down to the bottom. Apart from that, it's fairly self-explanatory. Just something you've got to know. Add a power, divide by that power. So adding a power, dividing by that power. So we'll look at a couple of examples. Find the general antiderivative of integral of that with respect to x. That value 3 there goes down to the bottom there. Add a power. So 6 divided by that, so 5 plus 1 is 6. 6 times 3 is 18. There's the rule. 1/18. So some of you are going to spot some shortcuts here, no doubt. So the 5 becomes a 6. And 18 is 3 times 6 is 18. Don't forget your plus c. What about b? So let's see if this works. -2, lose a power, -1, -2 times 2 is 4. Oh, no, so it's -1, isn't it? -1. That's -1 times 2, -2. So half. Well, maybe it does work. I'm sure you'll work it out. You can use your CAS. What about when r is -1? So the integral of 1/x with respect to x, let's write it in this form. X to the power of -1, add a power, divide by that power, we have a problem. Luckily, thousands of years ago, mathematicians fixed that problem for us. Talk to yourself. It ends up being ln, or log base e of x. Don't forget. So natural log, ln, is log of base e. So what about this one? What about this one? Oh, when we have the integral in it, when it's in the form ax plus b, so 1/ax plus b, 1/a log e ax plus b. So nothing unusual there, just something we've got to remember. Those two things are the same. Can get a bit weird here. If that value is greater than 0, we've got ax plus b. And we've got a weird case where if ax plus b is less than 0, it's -ax minus b. But we'll look at that in a little bit more detail later on, but just be aware of that. And natural log of x is the same as log base e of x. Just to clear something weird up. So integral of 1/2x. Take the half outside. Half of the integral of 1/x is going to be half ln x plus c. Easy. So what happens if we sort of just put it in that other form, like ax plus b? So it's 1/2x plus 0, because 2x plus 0 is just 2x, isn't it? So those two things are the same. If we use that rule there, we end up with a half ln 2x plus c. They're different. They shouldn't be different, should they? They should be the same because it's the same thing. Or are they? Ooh, spooky. It's just that these C's are different. So this one here might be a half ln x plus 10. This one might be a half ln 2x plus 5, and they actually end up being the same thing. I'll show you. So, first log rule. Log base A, mn, so just add them together. So that means that this here, a half ln 2x plus c, we can write as a half, and we've got a bracket, ln 2 plus ln x, close bracket, using this rule. So just multiply out the bracket. So you get a half ln 2 plus a half ln x plus c. And that's a constant, and that's a constant, isn't it? Because there's no variable in there. So they're both constants. So really, it's a half ln x plus a constant, which is what I mentioned before. But these two are the same. It's just the constants are different. So you're going to get some weird things happening. So when you come across that, that's what's happening. Ah, weird. Find the general antiderivative for that. That is greater than 3 over 2 or less than 3 over 2. So there's the one where it's greater than. There's the one where it's less than. So we end up with 2/3, 2 minus 3x, 3x minus 2. So these are just swapped around the other way. Similar, but different. Absolute function. So it's just telling you that you just ignore the sign. So I think we call it mod. Mod minus 2 is the same as mod of 2, which is just 2. So we can say that mod of ax plus b is that, when we just ignore the sign. So we can end up with just one formula for integrating 1 over ax plus b if we use the modulus sign. We don't have to worry about there being two different solutions. Same-ish. So given that the differential is 2 over x, and when they tell us these two things, that means we can find c, doesn't it? Find an expression in terms of x. So we've got one where it's x coordinate is -1, y coordinate is 10. Next one where it's x coordinate is -1 and y is 10. So we do the same process. We do the integral, and we end up with 2 ln mod x plus c. Let's shoot in. So we get 10 equals 2 ln 1 plus c, and c ends up being, so 2 ln x plus 10. Do with this one, still ends up being 10. Same answer. So there's our summary. We've got to somehow remember these. So these are the different ones, or more conveniently, we use this one, yeah? So just make sure, if you just writing those in, save you having to do those two different ones. When you do the exercises, you'll see it when you're doing the work. Antiderivative of e to the kx. So when we did the differentiation, we know that if you had e to the kx, when you differentiate it, that k comes down and this stays the same. Similar rule when we're integrating. So integrating that, 1 over k. That stays the same, plus the c. So nothing amazing there, just something we've got to remember. And often when we do calculus with e, it's actually, the actual mathematics involved is not too tricky. Find the general antiderivative for each of the following. So that 4 just goes down to the bottom, plus a c. 5 goes down to the bottom. Don't forget, we just have to treat that one, add a power, divide by the power. So we add a power to that's a 2. 6 divided by 2 is 3. Don't forget to add our c. That one there, that 3 goes down to the bottom. 2 becomes 2x plus c. And here we've got 2 of them with ease in. So you've sort of taken a -1 to the bottom. So it's obviously you don't have to turn that into a fraction. So it just becomes a minus e to the minus x. That stays the same. Plus c. Don't forget your plus c. A wordy question, or a kind of wordy question. Giving us a point, that tells us we're probably going to have to find c. Tangents. When you see the tangent, you're thinking sort of. Use whatever notation you want. You can use, your dy by dx and all this sort of stuff if you want. But here we're using function notation. So f dash of x equals that. So we've got to go back the other way. So that 2 comes to the bottom. This bit stays the same, plus c. That's f of x, isn't it? Because they've given us the notation there. F of x. That's the differential. That's the original equation. And we know that when x is 0, it's 7.5. So 7.5 equal that. Anything to the power of 0 is 1. So take away the 2.5, c is going to be 5. So there's the equation. Find the equation of the curve. There it is. Here's a question. So page 493, exercise 11C, question 7. Just thought it was a bit of a weird one, and thought I'd just sort of show you how to do it. The first one. So find an antiderivative of the following. Tricky to do it when it's in that form. So basically what we're going to do is we're just going to do a long division. So we're going to divide, remember that means x divided by x plus 1. So we just do long division. X is into x. Put a zero on it just to keep, so like our hundreds, tens, and units. X is into x, go 1. So then I times that by that and that by that. So 1 times x is x. 1 times 1 is 1. Take them away from each other. Obviously that's 0, 1. Sorry, 0. Take away 1 is -1. So that means x divided by x plus 1 is 1. This one here. Minus, and that's the fraction, isn't it? 1 over x plus 1. So now it's much easier for me to integrate it now. So I can integrate that, just going to turn into an x, and I can use the rule to integrate that. So x minus ln x plus 1 plus c. That algebraic long division that we did last year. Oh, yeah, ages ago. So don't forget little things like that. Okay. Another exam for you, another exam question for you. 11C and 11D. Enjoy. Mr. Patch, over and out.